The first one. Second one? Third one? Okay, well this is of course whatever where log 60 over log 5 equals, I'm sure you can come up with some number. This one, if it's log base 5 of something over log base 5 of something over log base 5 of something else, you can, if it's log the same base there, you can just write it as log base 2 of 7, right? That's as a single logarithm. I know I gave you all that space, but what? Well, you could write it as log 7 over log 5 over log 2 over log 5. You could. No, and then you could, if you have fraction divided by fraction, I mean, this would be worth remembering from grade 8. If you have a fraction divided by another fraction, what is that the same as? Yeah, multiplying by you could either, to get rid of that, you could multiply the top and bottom by log 5, and you'd get to this expression only in base 10 logarithms. Or you could write it as, if you remember that, you know when you had like 1/3 divided by 2/7, what did you change it to in grade 8? 1/3 times 7 over 2. You didn't write it as 1/3 divided by 2/7 in grade 8, but it's the same thing. This is two fractions divided, so you could make this, you could just write it as, take this second thing and flip it over and multiply by it, right? You could change it to this as log 5 over log 2 if you wanted. I'm not saying this is how you would have to do it or anything like that. This is the long way, I guess, of getting there. And then maybe you recognize the change of base rule here. Log 7 over log 2 is log base 2 of 7. However you get there is fine. This one maybe is tougher. If you're changing something to base 9 logarithms, this is equivalent to log base 9 of y over log base 9 of 3. The only problem is, if it says in simplest form, we can probably simplify this a little bit. What's the log base 9 of 3? What power do you, if you're taking the log base 9 of 3, you're saying 9 to what power gives you 3? 9 to what power? A half, right? It's like the square root of 9. So this would be log base 9 of y over 1/2, which is the same as 2 times log base 9 of y. So that's what that's equal to. There's probably other ways to get there that maybe some of you did. Anybody have a different way of getting to that result, same result? No? For this one down here, you can do the same kind of thing and just rewrite this expression on the bottom. Keep track of your fractions as you go. That's the same as 1 over log base, well, if we want base 25 logarithms, I guess, log base 25 of 5 over, make sure you keep track of where the actual fraction starts there, log base 25 of y. If you have 1 over that fraction, how could I simplify that just to make it easier before I do anything with this? If you have 1 over a over b, what's that the same as? B over a, right? It's just the reciprocal. 1 over 2/3 is like 3/2. So you could write that as log base 25 of y over log base 25 of 5. It's kind of similar to the previous one, right? 25 to what power gives you 5? What's the log base 25 of that? It's a half, right? So you got log base 25 of y over a half. So it's 2 log base 25 of y. Similar to the previous one. It's similar to the previous one other than it's the reciprocal of that. You could write sort of rules for yourself, making all kinds of things equivalent here. If we did something like that, I actually should have kept it as of 3 there. These are almost the same, these expressions, other than the 5 and the 3. I think you can learn something that log base a of b is equal to 1 over log base b of a. Okay, you could write a rule like that for yourself. I don't know if that's going to be a useful rule to you or not, but you could write an endless number of log laws if you want to. Just like you could probably do the same thing with exponent laws. In grade 9, you could write a whole bunch. You only learn 4 or 5 of them, but you could write 10 or 20 of them, probably, all these little specific things. It's a question of how much you want to memorize. This last one here, you can change those fractions. Complex fractions, I know, are difficult. As soon as you make a fraction within a fraction, but you can make that thing into a fraction with a change of base rule. 2 over log m over log 4. Unless it says use some other base, I would just use base 10, because if you have to put on your calculator. Plus 1 over log m over log 8. What can we do with that? Let's do the easier one with the 1 on top. 1 over a fraction, what's that the same as? Yeah, reciprocal, log 8 over log m. So does it work when there's a 2 on top? No, it doesn't, right? 2 over 1/4 is the same as 2 times 1 over 1/4, right? The 2 is separate from it. So what would that be the same as? 2 times 4 over 1, right? So what's this going to be? I'm going to leave the 2 kind of in front here. 2 times log 4 over log m. The fraction flips over, but the 2 doesn't suddenly go to the bottom. Right as a single logarithm, we've got to keep going here, I guess. We have 2 log 4 over log m, and we have log 8 over log m. You got to see these as fractions, and if you had a over c plus b over c, what could I write that as? If they have the same denominator and I'm adding them, sorry, my plus sign looked like a times sign. If I'm adding, those, it's going to be a plus b over c, right? Like if you have 2 sevenths plus 3 sevenths, you have 5 sevenths, right? You're adding fractions. You don't change the denominator, right? So if it's that plus that over log m, the denominator is going to be log m. It's not log m squared or anything like that. When you're adding fractions, the denominator stays the same, right? By the top, 2 log 4 plus log 8. You could change this 2 log 4. What could you change that to? Log of 4 squared, or log of 16. Log m. So what is this? Log of 4 squared plus log 8. It's 16 times 8. Log of, I'll write it like that first. 4 squared times 8 over log m. What is that? What is 16 times 8? 128. Whoops, it's m on the bottom. So we got log 128 over log m. I'm kind of showing every single step here. I mean, that's not always necessary, but so you could write this as log base m of 128. The only place that is a useful skill is in Math 12, I would say. It's not often you want to change things to base m, but it's a very theoretical part of the course, right? So there's lots of things to try. The questions in the practice book don't all look like these questions. There's different things. There might be some equations to solve that involve change of base. The practice stuff in the practice booklet has some things that look like this, but it has some different things, some equations to solve. It is worth you doing those questions, I would say, very much so.